Hello, this video clip is about to make up one of our lectures, which could not be done due to religious Bayram holiday of our course ele336 microprocessor architecture and programming, corresponding to week number 7. And related topic for this course is x86 microprocessor assembly programming, lookup tables, and associated instruction xlet. So, lookup table is a kind of structured array in the microprocessor's memory so that each array element number or index represents a kind of offset location in the memory to find the corresponding uh, data in a tabular structure. So if for some reason any program needs a group of data which calculation is a little bit difficult, then lookup tables are used because the result is immediately fetched from the memory. One of the examples is very simple, basic example. Actually, you don't need to have a lookup table to find any square of any number because that's a simple multiplication equation or operation. But for the simplicity and its compactness, it's good to begin with this example in lookup tables. So assume in any program you want to obtain the square of any integer number immediately. Okay, so between 0 and 9, you can use the lookup table. 0 and 9, you have to be careful about the structure because if you use byte location, then the maximum positive integer is 255. So you cannot have squares of around 144, 16 or 17, because then you exceed the limit of byte. So if you want to have squares of any numbers, then you have to consider the maximum number can fit into desired memory location or not. Anyway, so this is the constraint of data storage. Assume this is 0 and 9, so you first define the database labeled as square table defined by 0, 1, 4. You can follow from this integer. Note that each integer's index is the same as the integer itself. So if you know if the integer value is given, then it's a simple offset instruction to pick up the square of it. So from this database, we just access any number at any order. So the program gets okay, after the codes in the code section, move bx offset square table gets the offset address of the first data byte. Then you assign low byte of register AL because that's a requirement of the xlet that uses AX register. You get any number and xlet operation just replaces that number with its corresponding value in the lookup table. So that's as simple as this. Two-line command. Actually, squaring is not very useful to use xlet. Well, that's okay. But if the operation is rather complex, lookup tables are really good choices to optimize the software code of the program. This is another example, ASCII code convention. Well, definitely you need to use lookup tables because there's no direct operation to get any ASCII code of any symbol at hand. So you can follow from the code data segment, okay, as marked. That's an ASCII table of uh, symbols in hexadecimal data or symbol sets from 0 up to F. So there are 16 symbols. And hex value and ASCII values are defined byte variables to store the result of the operation. Then the code segment is very similar. First, you store the offset value in register BX and then get the hex value of any number, store it to AL. XLET operation picks up the symbol corresponds to that symbol and moves it to the memory. So this is a very good example of lookup tables. Well, there may be other applications of XLET. For example, some trigonometric function returns, etc., could be stored as a tabular forms, and XLET command can also be used to retrieve them. That could be enough, and more will be upon you in your self-study, as well as some homeworks may be given to practice your skills. Now we come to another crucial topic. That's the end of the software part of our microprocessors, microprocessor assembly instructions. So a group of instructions related to strings will be presented in the following slides. Strings are very special data structures. Those are arrays of bytes or words. The string array has a beginning character and EOS, which is end of string character. So you have the offset address of the beginning character of the string, and the length of the string could be indeterminate. The only requirement is you have to have an end of string character, which is the dollar sign in 8086 microprocessors. Besides, any string array element occupy a block of continuous memory space so that you cannot have half of the string is at some location, then comes the, you have to be connected memory chunk to deal with the strings. Well, strings are actually ASCII codes of some symbols. Those could be some alphanumeric characters, some text arrays, etc. And here is the summary of string commands in very good tabular form. So you can move, so-called move a string. That means you can assign some values as string arrays. This array could be either byte array or word array. So actually for the same move operation, there are two assembly commands ending with letter B or letter W, sorry. So if that ends with B, that's move string byte. Each character is or each element is a byte value. If the ending is W, it's a word value or 2-byte value. So besides moving string or copying some values to some locations in the memory, you can compare the string, either byte or word format. So you can compare two strings at two different locations, and they are compared byte by byte. Any failure to be identical value, then this gives false outputs, false logical outputs. You can scan a string, either byte or word, for a specific value is present or not in the given string till the end of the string character. So all the strings should have end of character symbol. You can load a string, so that creates a string with a given value. So any, let's say, value at some location of the string could be copied to a low byte of the register A or full word register AX. Or store a string means any value in that register AX, low byte or full string, full 16-bit register can be stored to the end of the string. So actually, by giving continuous variables to A, register A, you can load indefinite number of characters as a string. Other than that, string operations are not so different than move or other related byte or word oriented commands. The only difference is they are array type and indefinite number of times they can be repeated by the assembly program. So here's a little example which is from the text, borrowed from the textbook, about moving a byte string which starts with our usual offset command of the MA886 and then jump start goes to the beginning of the code segment so that data part of the or data segment of the code is skipped in the assembly programming, and that data part is a message. So that message is put into quotation marks so that this quotation mark says that it's a string and each symbol of the string is stored in the memory at the corresponding defined byte location in the memory, which is set by the assembly compiler. And 3 characters are added to this message. These are end of line and carry return successively. And the final one is 24 hex is the end of string character or dollar character. So the program starts with the label start, moving the value of the offset at the X register, which assigns the offset value, 16-bit offset value to the register DX, 16-bit value of the offset of the message array to the DX, and source index register is copied from that DX. Why? Because as we know, we cannot directly assign some values to SI. We have to first copy to normal general purpose register and then copy it to SI. Then we move a value of 0717 hex to BX register. So this is for assigning extra segment register ES, which is the last special register for offset of the string, and then this is copied to extra segment. Then DI, destination index register, is arbitrarily set to 0, and copying starts with 13 characters. As you can follow, there are 13 characters, full 13 characters in the message. Alternative way is you can check each string character. If it's an end of string character, you can stop copying. That's better for indeterminate number of character copying in a string. So the loop continuously copies of byte elements of the corresponding string with the label name NX, and the loop repeats itself 13 times till the CX counter register value drops to 0. And the end of the program is realized with return command. Here you can see the screen snapshot of the program. If you write the program in ME886, then apart from the code of the program, you can observe the memory view as you see at the top part of the program window. The upper memory part you can follow from the ASCII codes as this message is written, and it's also copied to some other part of the memory with this by using this program. So this is basically the most simple and basic form of copying some part of the memory to some other part. You can also uh, develop this program to copy some part of the program to some peripheral memory device, etc. So this is the almost the same method which used to um, change the location of a stored array variable. Now, string variables, the important thing is extra segment register ES, and the offset is realized with BX or similar by using the source index and destination index registers applied on strings. Strings are blocks of arrays, and there's nothing so new about this because that's simply a move instruction. You can also create or define compare instructions, other instructions, or scan instruction to check any character exists, etc. And these will be one of the laboratory assignments in your practical applications. Now we are coming to the end of the assembly language of the microprocessor. You have learned all the critical ones, the basic ones, let's say, and there are derivatives and let's say subfamilies of these instructions available to complete all 117 instruction vocabulary of the microprocessor. We have not explicitly covered, but exists and useful. Other instructions are as shown, like escape or hold or return from interrupt or temporarily stop or standby. Nop is no operation. Wait. Loop, we have seen it. Loop, E is loop when it's equal to, etc. Or loop zero is when zero flag is set, etc. So those are additional and remaining commands could be useful in assembly programming. So that concludes all assembly programming of the microprocessor. Now you are ready to develop any of your own programs with any desired outputs, and that only depends on the number of practical examples that you deal with. If you analyze and design more programs, then you will be a better programmer day by day, better assembly programmer day by day. So thanks for watching and listening, and of course you can contribute to this video. I'll be very grateful, and see you in the lecture room face to face. See you. Bye bye.